what are the solutions to the system of equations y is equal to x plus 1 and x squared plus y squared is equal to 25? So let's first just visualize what we're trying to do. So let me try to roughly graph these two equations. So my y-axis, this is my x-axis, this is my x-axis. This right over here, x squared plus y squared is equal to 25. That's going to be a circle centered at 0 with radius 5. You don't have to know that to solve this problem, but it helps to visualize it. So if this is 5, this is 5, 5, 5, this right over here is negative 5, this right over here is negative 5. This equation would be represented by this set of points, or this is a set of points that satisfy this equation. So let me, there you go. Trying to draw it as close to a perfect circle as I can. And then y equals x plus 1. Y equals x plus 1 is a line of slope 1 with a 1 y-intercept. So this is 1, 2, 3, 4. Y-intercept is there. It has a slope of 1. So it looks something like this. So when we're looking for the solutions, we're looking for the points that satisfy both. The points that satisfy both are the points that sit on both. So it's that point. Let me do it in green. It's this point, and it's this point right over here. So how do we actually figure that out? Well, the easiest way is to, sometimes the easiest way is to substitute one of these constraints into the other constraint. And since they've already solved for y here, we can substitute y in the blue equation with x plus 1 with this constraint right over here. So instead of saying x squared plus y squared equals 25, we can say x squared plus, and instead of writing a y, we're adding the constraint that y must be x plus 1. So x squared plus x plus 1 squared must be equal to 25. And now we can attempt to solve for x. So we get x squared plus, now we square this, we'll get, I'm going to write it in magenta, we'll get x squared plus 2x plus 1, and that must be equal to 25. We have 2x squared, now I'm just combining these two terms, 2x squared plus 2x plus 1 is equal to 25. Now, we could just use the quadratic formula to find well, we have to be careful. We have to set this equal to 0 and then use the quadratic formula. So let's subtract 25 from both sides, and you could get 2x squared plus 2x minus 24 is equal to 0. And actually, just to simplify this, let's divide both sides by 2, and you get x squared plus x minus 12 is equal to 0. And actually, we don't even have to use a quadratic formula. We can factor this right over here. What are two numbers that when we take their product, we get negative 12, and when we add them, we get positive 1? Well, positive 4 and negative 3 would do the trick. So we have x plus 4 times x minus 3 is equal to 0. So x could be equal to, well, if x plus 4 is 0, then that would make this whole thing true. So x could be equal to negative 4, or x could be equal to positive 3. So this right over here is a situation where x is negative 4. This right over here is a situation where x is 3. So we're almost done. We just have to find the corresponding y's. And for that, we can just resort to the simplest equation right over here. Y is x plus 1. So in this situation, when x is negative 4, y is going to be that plus 1. So y is going to be negative 3. Y is going to be negative 3. This is the point negative 4 comma negative 3. Likewise, when x is 3, y is going to be equal to 4. So this is the point 3 comma 4. These are the two solutions to this nonlinear system of equations.
Find the coordinate of point of intersection of the system. First equation is the x squared plus 2x minus y plus 1 equals 0. Under that is another equation, which is the linear equation is x plus y minus 1 equals 0. We need to remove the y, so we need, in terms that we need the addition, then the answer will be x squared plus 3x plus 0 plus 0 equals 0. After that, the remaining equation will be x squared plus 3x equals 0. To get the x, or the answer, we need to distribute the x squared plus 3x equals 0. Then this will be the term x, open and close parentheses, x plus 3 equals 0. We assume that x is equals to 0, or x plus 3 equals 0. So the positive 3 will move to the right side, and it will become x equals negative 3. That is your answer for x. After eliminating the y, we substitute the x, or the answer we get, in the fastest or the easiest way, or the equation given, which is x plus y minus 1. If x equals to 0, then x plus 1 y minus 1 equals to 0, then y minus 1 equals 0. Then transfer the negative 1 to the right, will be y equals 1. That is the answer, so we will assume that the coordinates in the plot, or in the Cartesian plate, will be 0 and 1. Now we move on to substitute the other answer, which is x equals to 3, negative 3. If x equals negative 3, then negative 3 plus y minus 1 is equals to 0, and y minus 4 equals 0. The answer will be y is equals to 4 after transferring the negative 4 to the right. Then we assume that the coordinates in the y-axis under the Cartesian plate will be negative 3 and 4. After knowing or getting the x and y, we will get now the answer. Therefore, the point of intersection are what we get from our solutions are the 0 and 1 and negative 3 and 4. Here we are to the second example. Find the solution of the system. The equation we will get is y equals negative x raised to the third power plus 3x to the second power plus quantity x minus 3. And the linear equation we will get, or the given, is y equals quantity x minus 3. In order to get rid of n, or in order to get rid what we need to eliminate, so in the solution we will eliminate the y. We will use the negative or the subtraction. The answer will be 0 equals negative x to the third power plus 3x to the second power. After arranging the right place of the equation, the answer will be x to the third power plus 3x to the second power equals 0. Now we move on to the distribution, or to know the Now we move on to the second solution, which is negative x squared x minus 3 quantity x minus 3 equals 0. We distribute the negative x squared, which is parentheses, close and open close parentheses, negative x, close and open parentheses, x, then x minus 3 equals 0. So therefore, we assume that negative x is equals to 0 and x is equals to 0, then x minus 3 equals 0. Moving the constant term to the right will be x equals to 3 and x equals to 0. That will be the answer for our x. After eliminating or knowing what is the answer for our x, we need to substitute to know what is our y. We get the second equation from our given to substitute all the answer that coming from x, which is y is equals to x minus 3 then x will be y is equals to 0 minus 3. Then after the constant term moving to the right will be y is equals to 3, negative 3. That is the answer of our, or the second answer in the, or the first answer in the y. Next will be y is equals to 3 minus 3, then y is equals to 0. So we assume that our coordinates in the Cartesian plate will be 0 and 3. We assume that the coordinates 0 and 3 and 3 and 0. Therefore, our point of intersections are 0, 3 and 3, 0. We will now get to our final example. The given in our final example is x minus 1 to the second power minus y to the second power equals 9. We will notice that this equation is hyperbola. The other given, which is 2 times x minus 1 to the second power plus y to the second power equals 66. Then this equation, or you can notice that this equation is called or an ellipse. We will get rid of the same equation, which is x minus 1 to the second power, so we will use the addition. The answer will be 3 times x minus 1 to the second power plus 0 is equals to 75. Is equals to 75. To get rid of the 3, we will divide both sides or both constant terms and the variables into 3, which is 3 times x minus 1 to the second power equals 75. Divide all over to 3. We will now get the answer of x minus 1 to the second power equals 25. Now, we have a problem that x minus 1 has to the second power, so we will remove the power. So we will use, to get rid of the power, we will use the radical sign. So x minus 1 square root of x minus 1 to the second power square root. So the answer will be x minus 1 is equals to positive and negative 5. We assume that x minus 1 is equals to 5. Then x minus 1 is equals to negative 5. Then moving the answer to the right, or moving the constant term to the right of the equation, then the final answer will be x equals to 3, x equals to 6, rather, x is equals to 4. After getting the x, we will now substitute the x from our second given equations. If x is equals to 6, then x minus 1 to the second power minus y squared equals 9 will be 6 minus 1. After substituting the x from the equation, 6 minus 1 to the second power minus y squared equals 9 will be the answer, or moving on to the answer, which is 25 minus y squared equals 9. And we transpose the 25 to the right and leaving the negative sign to the y squared. This will result in the answer, which is negative y squared equals 9 minus 25. The answer will be negative y squared equals negative 16. Again, we will read the second power. We will using the radical sign to read of it. So y squared equals negative 16 will be square root of negative 16 will be y is equals to positive and negative 4. This is the answer in our first y. Then we will get to the second x. We will substitute the second answer, which is x might equals to negative 4 to the second equation. If x is equals to negative 4, then x minus 1 to the second power minus y squared equals 9 will be negative 4 minus 1 the second power minus y squared to the second power equals 9. 25 minus y squared equals 9. Moving on again, transpose the 25 to the right, we will get the answer of negative y squared equals 9 minus 25. Again, the answer will be negative y squared equals negative 16. We will remove again what we do last time. We will use the radical sign. The answer will be square root of y squared equals to square root of 16, and we will get the same answer as the first, which is y is equals to positive negative 4. So we will assume that the coordinates in a Cartesian plate will be 6 and 4, then 6 and negative 4. Then the second coordinates will be negative 4 and 4, and negative 4 and negative 4. That concludes the answer in our problem. To the third example, which we will give an example using the quadratic formula. Solve the system. The given equation are y equals to x to the second power plus 2x plus 1. The other equation given is y equals 2x to the second power plus 3x plus 2. We will get rid of the y again, so we will use the subtraction. Then the answer will be 0 is equals to negative x squared minus x minus 1. After arranging the correct arrangement of the equation, the answer will be x squared plus x plus 1 equals 0. After getting the answer of x squared plus x plus 1 is equals to 0, there are no answer, or we will not get the x and y, so we will using the quadratic formula. The quadratic formula, if ax to the second power plus bx plus c is equals to 0. So we will get the a, b, and c. In our answer, which is x squared plus x plus 1 is equals to 0, the a is equals to 1, b is equals to 1, c is equals to 1. the formula we will get is x is equals to negative b. We assume that positive and negative in our Cartesian plate, so we will use the positive and negative square root of b squared minus 4ac all over 2a. Now, we define the formula to know what is the final answer, so we will substitute the a, b, and c in our formula. Now, this will be the answer. X is equals to negative 1 positive and negative squared of 1 to the second power minus 4 times 1 and times 1 all over 2 times 1. Moving on to our solution, x is equals negative 1 positive and negative square root of 3 negative 3 square root of negative 3 all over 2. So we assume that, or therefore square root of negative 3 square root of negative 3 can't be grabbed. No real solution. Or therefore, no solutions.
Okay, class, that's the end of our class. Hope you learned something and give yourself a hug.